everyone. We're really glad to have you here for the next session of our Devon and Beyond Security series. Our topic today, as you can see, is securing applications with OCI Security Services. My name is Renu Bhatt. I'm a program lead with the Customer Enablement team. And today we have with us Amit Chakravarti and Kiran Thakur. Both are cloud security architects here at Oracle. And without taking much time, I would just hand it over to Kiran.
Thank you, Renu. Welcome, everyone. Good morning, good afternoon, good evening, depending on wherever you're joining us from. As Renu mentioned, today we will talk about securing applications on OCI. My name is Kiran Thakur. I'm Security Solutions Architect at Oracle. I work as part of customer engineering team and help customers secure their workload and applications on OCI. With me, Amit Chakravarti, he is part of the same team. Amit, you want to quickly introduce yourself?
Sure. So this is Amit here, Amit Chakraborty. I'm also a cloud architect specializing in OCI Security, and I help our customers with various security solutions in OCI.
Thank you, Amit. We believe in layered security in OCI. As part of application security portfolio, we have many services, but today's focus will be 3 services, as you can see on the screen. Web Application Firewall, which is layer 7 firewall to protect your applications on OCI. The next one will be API Gateway to secure your APIs, application APIs on OCI. And the last one will be Certificate Management Service. With that, I'll hand it over to Amit. He will cover Web Application Firewall service on OCI.
Thank you, Kiran. So let's look into WAF, that is Web Application Firewall, and how it can help you in maintaining a secured environment. So let's look into a use case. So where does this requirement for the WAF come from? Why WAF in the first place? So here you have a very typical environment where you have a bunch of actually web applications which have been deployed in some virtual machines or say in your Kubernetes clusters, and typically you would deploy them in a private subnet when you deploy them in OCI, and you would, for high availability, you would front end these web application by a load balancer as depicted in this diagram. And so on the extreme left, you have the end user who is actually accessing this web application, but it actually goes via the load balancer. So this is a typical case, right? This is the typical use case. And so now as we saw, I mean, there was no actually gatekeeper. Nobody was actually seeing who is entering, who is trying to actually access those web applications. Here you have a bad actor. He enters the scenario, and the bad actor has a free pass and starts injecting malicious payload while accessing those same web application. And so that is what can actually cause a lot of actually harm to your organization and to your web applications. So that's why you require some kind of solution, which is a web application firewall, a firewall solution, which will inspect requests and block or allow traffic as required. So the customer benefits are basically you get a layered defense and flexibility to enforce various security in region and which is closest to your application. And the WAF will actually protect applications from malicious and unwanted internet traffic. It can also protect any internet-facing endpoint, providing consistent rule enforcement across a customer's applications. And being a native OCI service, it is actually tightly integrated with OCI IAM, and in fact, the OCI IAM policies are basically, can be used for control plane access management. For observability, it is, it uses the OCI logging service, and it integrates with the logging analytics. It has some built-in metrics also, which can be actually leveraged. And we will have a look at some of them later in the presentation. So OCI WAF has 3 important features. access control, protection rules, and rate limiting. The OCI WAF acts as a reverse proxy that will inspect all traffic flows or requests prior to these arriving at the origin web application. It will also inspect any request going from the web application server to the end user. This is a very powerful and is a very powerful feature, and it will allow you to inspect egress traffic from your application servers as well as protecting your servers from outside threats. Regarding access control, you can use the user access control to restrict or control access to your web applications. As an example, regional based access control is perfect to keep your clients to access applications that are in a specific region. Another use could be to block countries from getting to your application servers entirely. For example, if you don't do business with certain countries located, you can completely block access from these countries. You can also activate the user control access based on HTTP header information, or it can be based on URL addresses. Regarding protection rules, the OCI WAF is a cloud-based WAF solution, and it supports about closely about 500 odd protection rule sets, as well as the Open Worldwide Application Security Project, which is the OWAPS rule sets. You can use these rules to protect your critical web applications against malicious cyber attacks from bad actors, as we saw, earlier in the diagram, in the figure, when we are looking into the classic use case. These rules are compared against incoming requests to determine if the request contains an attack payload, as compared to industry-leading threat feeds. If the WAF determines that the request is an attack, it is going to actually block or alert that request. So these attacks are many and varied and include threats such as SQL injection, cross-site scripting, HTML injection, and many more, all of which can be detected and blocked by the OCI WAF rule sets. And when we go into the demo part, when we have the console walkthrough, we can actually look into these rule sets in more detail. Regarding rate limiting rules, rate limiting is often employed to stop bad bots from negatively impacting a website or application. Now, attacks that rate limiting can help mitigate include brute force attacks, denial of service, and distributed denial of service attacks, kind of.
Hey, Amit, question
Yes.
on the last slide. Can you talk a little bit more about using rate limiting feature to prevent DDoS attacks?
Right. So that's a good question. So what happens with the rate limiting rule is that you define that what is the frequency, of request which your application can actually safely handle without getting overwhelmed in a certain period of time. So, in other words, say for example, your web application can handle, say, about 1,000 requests per second. Then of course you can actually, if it starts receiving more than 1,000 requests in that interval time, which is say 1 second, then the rate limiting rule will kick in and try to actually, stop any more further, requests coming to that, basically being transported to the web application, so that your web application doesn't get actually overwhelmed and can actually service requests. Now, the important thing is that the rate limiting rule is applicable per client per client. So if there are two clients of the, and one of them is say kind of actually a bad actor and would like to actually, pump in or send, say instead of 1,000 requests, it starts sending about 10,000 requests, right? So the rate limiting rule of WAF is going to actually, look into that, will understand that this particular client, is trying to actually bombard, requests, and therefore, trying to actually basically have your web application server basically use all its resources in serving that particular client. Thus, rest of the clients will be all, kind of starved. So it's a very nice feature. It's a very helpful feature, and it can actually basically thwart attacks from selected clients, because it works at the client level. And the rest of the other clients, which are actually good actors, they will continue actually, sending requests, and they will be served normally. So coming to the logging, since it's a native service of OCI, just like any other service, OCI services, it is also integrated with the OCI logging service, and we will also look into that when we go into the console walkthrough. So now let me actually quickly go into the console, and we'll look into a WAF demo. But before that, let me walk you through the console and check out the various WAF features we have discussed so far. So here I am. I have already defined a WAF policy here. As you can see, it's called the Amit apps. And it has been actually just like, since it is a OCI service, it has, just like any other services, it is actually defined in a certain compartment, as you can actually see over here. And as such, again, as we actually saw in the presentation earlier, the three features, namely the access control, the rate limiting, and the protections. So these are the three features which WAF actually supports. So for over here, I have already defined certain access control rules. As you can see, I have already defined a rule which is stating that, basically I'm going to actually allow traffic only which originates in US. Similarly, I have actually defined various other rules. And in this particular, the second rule is slightly more sophisticated, as you can see, that it is actually defining various URLs which can be actually accessed using the HTTP GET verb. For example, over here, I'm actually saying that any, if a request comes and tries to access any resource starting with /test, I'm going to actually allow it. And of course, the verb has to be get. So you're trying to actually fetch resources from the web server, which all start with, /test. And there is another rule, which is, a similar kind of rule, but which actually works with the post verb. And regarding the rate limiting also, I have actually defined some other some rate limiting rules. And the protection is the heart of the WAF. Now, before I actually go into the protection, let me actually just talk a little more about the access control. Uh, as we discussed during the presentation, over here I have defined these three rules. But you can actually, define rules not only using the country region, which I have actually defined, allowing only from US, but a combination of various rules using the request method, which is, like get post, an example which I have also done over here. But then there are other attributes of the HTTP request which can be actually used. You can use the cookies. You can actually use the headers present in the HTTP request, the URL itself. You can also basically define certain access control rules based on the IP addresses and so on and so forth. So as you can see, access control rules actually gives you a very sophisticated, very powerful, a mechanism, a tool, which you can actually use to define various firewall kind of rules. So this is the access control rule, and what happens is that, for example, once the rule actually kicks in, you can actually define what actions you would like to actually take. Out of the box, OCI actually gives you three of them: the check action, pre-configure check action, or allow, as well as the 401. But you can also define your own actions, and that's what I have actually defined. For example, I have defined. So these are the three. The top three are the pre-configured ones, and the fourth one I have defined, and it basically sends a 403. And this is the rule which I have actually used consistently in all my access control, and so on and so forth. The protection one is similarly, you can actually define various OWASP based rule sets. I have, as you can see, I have actually defined various protection rules here, but let's look quickly, go and have a look into that. Um, into how they look like. So here this is an example of various rule sets which OCI actually OCI WAF actually gives you provides and you can use these protection rules to thwart any kind of attacks coming in the payload. So here you can see these are the rules for the SQL injection, then the cross-site scripting, the PHP injection, RC, for the Windows as well as for the Linux group, and so on and so forth, right? So LFI for LFI kind of actually attacks you can actually protect. So these are, and it's very sophisticated. It's not, I mean, this you can actually define various kind of OWASPs um, rule sets. Taking any one of them, you can actually choose the rules which are actually basically defined by the OWASP group. You can also define rules which basically are help you to thwart any CVs. Similarly, you can actually define the rules for various applications. Like these are the different types of actually applications, and for the Jira, for Log4j, and so on and so forth. Similarly for the platforms and the databases, and so it's a very comprehensive one. It's a very powerful tool which you can actually use to protect your web applications. So let me actually show you some demo. How it's a very simple demo, and then we will see how this is actually being handled. So here I am. Um, Let me just go and so I'm trying to access my site, which is actually protected by the WAF, and this what had happened is that this is actually accessing the test.html. And if you may recollect, when we were actually going to the access control rules, any particular URL which actually starts with /test should have been actually allowed. And since this is not actually carrying any kind of actual payload, this is actually let go. I mean, WAF actually inspects the request and actually allows to move forward. Similarly, I have another request, but this time actually it is having some payload, which is not a payload. It is actually having a script which is actually part of the query itself of the URL. But you can always send it through the payload also, yeah, had it been a post request. But this is, I'm actually accessing the as a GET request, and here I see that it has been actually blocked. Now, a while back, we also discussed that OCI WAF being a native service of the OCI, its logging is actually integrated with the OCI logging service. So here I can actually come and this is the logs. I can actually so um, let me just go back. And the way, so the WAF, there are two things. One is the policy itself, and then you have to actually attach it to the load balancer. In other words, the load balancer becomes a enforcement point, as we saw in one of the diagrams earlier, right? So and now from that, for that particular firewall object, I can actually go and see what kind of logging information has been actually logged. So let's look into that. And here I see that that one request has been actually blocked. And if I can actually inspect that request more, that you see that it is trying to access the fab icon.ico. Now, none of the rules, access control rules, one of the access control rules is that it should be from US. Also, it should be, starting from /test. This doesn't match. This doesn't match. And therefore, the response is going to be 403. And the response is basically, since it doesn't match, it actually, the WAF has actually, the access control policy of the WAF has kicked in. And let us actually try to see if it has actually logged any more further messages. So here there are a few more actual messages which have been which are actually showing, and let us actually see that here. So this correspond to this particular request over here, where we are actually trying to send some bad, cross-site scripting, cross-site scripting actually kind of uh, payload. And as you can see in the logs, it has the path is showing that it is actually test.html with that particular cross-site script. And the request action, the access control rule allowed it because everything was starting, the URL was starting with /test, whereas the request protection actually now sees so that this is the matched ID 94111. And if I go back into the policy over here for the Amit Mobile, managed request, and if I go into over here and look into this, this is one of the cross-site scripting protection rule which has been actually defined by my WAF policy, which has actually kicked in, and therefore it has actually basically protected the web application from this particular injection. So this gives you a very, a brief overview about how the WAF access control rule, as well as the protection rules, all of them actually help you in securing your web application. So that kind of actually concludes my presentation. And Kiran will discuss now about the next topics. So Kiran, over to you.
Thank you, Amit. All right. Let's talk about API Gateway now. API Gateway, as the name of the service suggests, it's a gateway to your APIs, whether your APIs are running on OCI, or they are running on-prem, or they are running anywhere on any other cloud. Remember, multi-cloud is the theme at Oracle. API Gateway is a serverless, fully managed service on OCI. It's a regional service. So within a given region, we give you full HA and DR solution. What I mean by that is when you spin up an API Gateway service instance, we create multiple instances and put those instances across different availability domains in a region, or if it's a single region, or if it's a single availability domain region, then we create multiple instances across all the fault domains in that given region. The service instance runs within customer VCN. So if the VCN is public, then your API gateway instance will have public endpoint, meaning accessible from the internet. And if you create API gateway instance in private VCN, then it will not have public endpoint and will be accessible only within your VCN, and applications running in that VCN will be able to connect to API gateway, of course, provided you have appropriate security list and network security groups created. API gateway does support custom domains, so you can create vanity URLs. By default, when you create an instance of API gateway, it will give you an endpoint with oci.customer-oci.com domain. But as I mentioned, you can create custom domains and create, let's say, application API.customer.com domain and use that for your API gateway instance endpoint. It is available in all the regions, meaning commercial, Gov Cloud, dedicated cloud at customer, in all the different flavors of cloud, and in all the regions of a given flavor. It does support stock responses and client SDK generation. So for example, you're building an application, the backend application is not ready yet, but you want to start building your front end of the web application. You can put API gateway in the front, and API gateway can return stock responses for API calls. And using those stock responses, you can continue development of the web interface. From networking perspective, since the service runs in customer VCN, customers can use all the security controls of VCN, like security list and network security groups, to protect API gateway instances. It does support service gateway as well. So if you have service gateway deployed in your VCN, API gateway can and will use service gateway to connect to other OCI native services. From security perspective, it is protected by OCI IAM service. So you have to write IAM policies to allow your control plane users to be able to manage or perform CRUD operations on API gateway instances. The service is integrated with certificate management service to manage certificates for your API gateway instances. It does support mutual TLS. So if you have a requirement to support, client certificate validation as well for your API gateway instances, you can, the service supports that. You can build custom trust stores as well for your backend API endpoints. Policy enforcement, as I mentioned in the beginning, it acts as gateway to your APIs. And on that gateway, you can enforce certain policies, certain security policies to protect your backend APIs, from sort of malicious usage, or sort of block those requests at the gate instead of letting them hit your APIs and affect performance of your APIs. From enforcement perspective, it supports these sort of policies. First one is OIDC and OAuth support. It can act as sort of proxy or gateway to your APIs and enforce OIDC support. This is, if you have a legacy application that doesn't support modern authentication protocols, you can put API gateway in the front, have it enforce modern authentication, and then to configure trust between API gateway and backend application to support, the legacy authentication. And the way you would do that is by writing custom authorizer function, which, as you can see on the screen, it does support rate limiting as well, which is again same as WAF. You can configure how many requests do you want to allow per client, per endpoint, and API gateway will enforce that. And you can use that to support billing as well. So let's say you have an application and depending on the subscription type, you want to allow X number of API calls in a minute or in a second. You can use those data to enforce rate limiting for different types of subscribers. It does support request validation, meaning it can look into request headers, and if it has any malicious headers, then it can block those requests. One very common use case is blocking requests with basic authorization headers, because most customers, and as part of NIST recommendation, most customers do not want to support basic authentication. You can use API gateway to enforce that restriction. It does support request response transformation as well, meaning you can transform request and response headers. And if you want to add additional headers or remove or append more information to headers, you can do all of those manipulation at the API gateway. And it does support dynamic routing as well to your backend APIs. Since it's fully managed and OCI native service, like WAF, it is integrated with OCI's observability and management platform. What that gives you is, it gives you audit logs. If anyone tries to, do any CRUD operation on the API gateway instance, and I'm talking about control plane now, all those control plane requests on API gateway instances are logged in audit logs. It does integrate with OCI logging service as well. That helps you capture, your API gateway instance data plane logs. So, once API gateway instance is created, when API when API clients start hitting your APIs, you can capture those logs in OCI logging service. And there are two types of logs that are supported by API gateway: access logs and execution logs. Access logs will basically tell you, hey, someone tried to access API/home, and execution logs will show you when/home API was hit. What did API gateway do? And you can take those logs and integrate them with logging analytics to show you sort of nice dashboard of all the requests that are hitting your API gateway instance, and look at different parameters like, hey, I want to monitor average response time. I want to monitor how many failed requests were served by API gateway instance. You can see all of those, data through logging analytics dashboard, or you can take those logs from OCI logging to your preferred SIEM solution and view those data from the SIEM service. It is integrated with monitoring service as well. So you can see all the metrics like, um, how, again, what was the response time, how many requests were received, how many of them were successful, how many of them were failed. If they failed, did they fail with, 4x response, or did they fail with 5x response? You can see all of the data in metrics. Now let's look at some of the use cases. You can use API gateway to sort of front end your APIs. APIs could be running on compute instances. APIs could be running on OKE clusters, on any other container platform that's running on OCI compute. Or you can also use API gateway to front end your OCI functions. And when we see the demo in action, we'll see that API gateway invokes OCI function behind the scene. You can also put API gateway in front of your object storage calls. You can also put API gateway in front of your OIC endpoints. And this is, by the way, one of the very common and most used use case of API gateway in OCI. Most of the Oracle Fusion customers build their integrations using OIC, Integration Cloud Service on OCI, and they want to protect or enforce security for those OIC APIs, and they put API gateway in the front. One other use case of API gateway is, let's say you're running data center exit program. Some of the applications have already moved to the cloud, and some other applications are still running on-prem, and those cloud applications need to access your applications running in the cloud. You can put API gateway between your applications running in the cloud and your applications that are still running on-prem, and route those API requests from OCI to on-prem applications. One other use case is, let's say you're running application modernization program. You have moved your applications to the cloud, but due to sort of time crunch, you are only able to modernize some applications, and the rest are still sort of legacy applications and continue to sort of use legacy authentication, like basic authentication. You have custom authentications built for those applications. And all the modern applications would then prefer to use protocols like SCIM or JWT tokens. You can put API gateway in front of your legacy applications, have it support modern authentication, and then use custom authorizer function to sort of create tokens that the backend application will understand or will accept, or do any other request transformation before hitting the request to the backend application. So, that again is one of the very common use cases of API gateway on OCI. Now let's look at demo live. For demo, I have very sort of unique use case that I helped a customer with about a couple of months back. One of my customers is running off-the-shelf application on OCI, and because it is off-the-shelf application, they don't control the application behavior and are not able to change the application behavior to support their requirements or use case. The application does support SAML authentication, but it can only integrate with one IDP. It cannot integrate with multiple identity providers at the same time. If we were to do this use case without API gateway and OCI function behind the scene, as you can see on the screen, you will have to put full-fledged SAML implementation in between, acting as federation proxy to process incoming SAML requests from the application, which is this application, and then route the requests to one of the IDPs, one of the many IDPs that you want to support at the federation proxy. And then again, in return, it has to process SAML response from these IDPs and then convert that into SAML response for your application. We came up with a unique solution to put API gateway in between. That's calling OCI function behind the scene. The OCI function will take SAML request from this service provider application, will take SAML authentication request and relay state from the request, will do all the manipulation that's required to change, let's say, destination in the SAML authentication request, and route it to one of the IDPs that the customer will choose to use to log in for that specific request. And with this, they don't have to worry about HANDR of this sort of federation proxy implementation. OCI function invocation barely will cost anything. API gateway, again, will cost minimal and will get full-fledged HANDR solution for their use case without changing anything on the service provider application and without standing up full-fledged federation proxy. Now let's see that in action. And before we do that, we will also look at my API gateway instance here. As you can see here, SAML utility is my API gateway instance. And behind the scene, when my SAML utility / IDP endpoint is invoked, it's calling this SAML utility function. And SAML utility function, as you can see here, will read SAML request and relay state from the request and will route it to one of the two IDPs that end user will choose from the login screen. So let's say I'm hitting the service provider application. For this implementation, I chose OCI IAM instance to sort of represent as the service provider application. When I use service provider application, it triggers SAML authentication with API gateway instance. When API gateway instance is invoked, it's calling OCI function. OCI function will be instantiated and will show one of the sort of many IDPs that you may have configured in your OCI function, and the customer or end user can choose one of those IDPs to log in with, and when you choose one of the two IDPs to log in, it will trigger SAML authentication with that IDP. And once the IDP authentication is done, suppose we do MFA. And once the MFA authentication is done, I'm logged into application console. My application console didn't have to support multiple IDPs. I could do that magic using API gateway and OCI function. It's little sort of unconventional use case of API gateway, but I wanted to show this use case to sort of show the power of API gateway plus OCI function combination. It can do many more sort of complicated use cases with very small piece of code running on OCI function. The second use case I want to show is API gateway enforcing modern authentication, which is OpenID Connect authentication for my backend applications that do not support modern authentication. The way you would configure that is for the API endpoint deployment, you will go to the definition of API gateway deployment, and you will choose what authentication you want to support. I'm saying I want to support OpenID Connect authentication. I want API gateway instance to call introspection endpoint of the authorization servers. This is the discovery URL for my authorization server. And client ID, client secret that it needs to connect to authorization service is stored in OCI secret. So we don't allow storing plain text client secret for that introspection endpoint. And here I can also configure that I want to enforce PXE for my OpenID Connect authentication. I can also configure API gateway to use cookies for session so that application side session can be maintained by API gateway, and you don't have to sort of redirect API gateway clients for OpenID Connect authentication for every single API gateway request. Let's see that in action. I'm hitting my API here. It does redirect me to my OpenID Connect server. I log in here. And here we are. I'm logged in, and we don't have time to look at the browser trace or cookies, but you will see that API gateway will create local session and will store local session information in application cookies. Moving on, let's talk about certificate management service on OCI. Certificates are used to enforce encrypted traffic on the internet. So the backend servers will go get certificate from certificate signing authorities to prove that they are who they claim to be. For example, when you hit google.com, Google has to prove, or that endpoint that you connect to from your user agent, which is browser, has to prove that it is really google.com. And the way it is done is google.com will go get a certificate from certificate signing authority, which is trusted by browsers, to prove that it is google.com, and it is certificate signing authority's responsibility to do domain validation and issue google.com certificate to only the entity that owns google.com domain. And then when you hit the application, server will present the certificate, user agent or browser will check with certificate signing authority and make sure that the certificate is not expired or is not revoked. And if it is not revoked, then it will trust the SSL certificate and will generate what is called a symmetric key for that HTTP session, which then will be used to encrypt the traffic on that particular session. It looks simple when you hit https://oracle.com and boom, you just see the page. That SSL, for that SSL magic to happen, as I mentioned, servers have to get SSL certificates for their domain, and that is quite involved process. First, they have to create PKI for their certificates, for their SSL certificates. Using the PKI, they have to generate what is called a CSR, certificate signing request. They have to then send certificate signing request to certificate signing authority, which then has to validate the domain. And once the domain is validated, then you will get signed certificate, which then you install on your web server or on your applications to be presented to the user agents or browsers or users who are trying to access your website. As you can see, it is quite involved process. And then as and when the certificate is expired or is about to expire, you have to repeat that whole process again, which is generate PKI, generate CSR, sign the CSR, and then install the certificate on your server. Certificate management service automates that whole process for you. So, for an application administrator who doesn't understand PKI or, who doesn't understand certificates, when they create load balancers or API gateway instances, those are basically two common ways how you expose your applications to your end users. When you create instances of load balancer and API gateway, you will just choose to say, I want to manage my certificates using certificate management service, and boom, they don't have to worry about generating PKI, generating CSR. They don't have to worry about all of that whole process that we saw on the last screen. It's a fully managed service on OCI. As of now, it only supports private CAs, meaning it can only sign private CA certificates. It doesn't talk to public CAs to get the certificate signed. However, if you have certificates that are signed by public CA, you can upload those PKI along with signed certificate and then configure API gateway or load balancer instance to use the certificates that you have imported that are signed by public CAs. It natively integrates with load balancer and API gateway instance, which basically makes the whole deployment easier. Benefits of using certificate management service: it automates the whole process for you. It automates renewals, as well as when it is about to expire. The service is gated by OCI IAM, so you can use OCI IAM policies to define who can access what. It does support certificate revocations as well, so you can revoke certificates that have been issued, and then it will enforce that restriction. And you can also create hierarchy of certificates with intermediate private certificate signing authorities from the root certificate.
Hey, Kiran,
Yes.
just a quick question. So this is regarding the certificates service.
Mhm,
So you mentioned that currently our OCA certificates actually supports only private certificates as
mhm,
a certificate authority,
mhm,
which is good, and you illustrated where we can actually use them.
mhm,
But since we don't support the public, it cannot act as a public CA.
mhm.
Where do you see the use cases? I mean, how would actually customers use our OCS certificates? Because
So
they will be requiring the public one, but at the same time, how do you see that they can actually use our OCS certificates also?
Yeah, thank you. Thank you for that question, Amit. As I mentioned in the last slide, if they have public CA signed certificates, they can import them and use with certificate management service. But other common use case of certificate management service is using private CA signed certificates for your non-production workloads. You don't want to pay
Mhm.
your CAs to sign your non-production certificates. It can, reduce your cost substantially. Uh,
Right.
and the second use case is, let's say you're running microservices application on OCI and you want to use SSL between different modules of your microservice application. Then again, you can use API gateway with certificates from certificate management service. And again, because it is internal
Mhm.
traffic between different modules of your microservice or different services of your microservices application, you don't really need CA signed certificates, and again can reduce your cost substantially and still offers you same level of TLS
Security.
security.
Right, right. Okay. Thank you.
Thanks. In terms of enforcement, as you can see, when you create load balancer and API gateway instance, you just choose to use certificates from certificate management service. And when customers try to access your applications, which could be running here on virtual machines, these will enforce SSL trust, and you offload SSL here and connect to your backend applications over HTTP. That's about it. These are some resources that you can refer to for all three services: Web Application Firewall, API Gateway, and Certificate Management Service.
I would like to give an opportunity to Chris to add something if he wants to about the content that was presented today.
Sure. I mean, I guess just mention, you saw a few things that we did with the API gateway. There's some other things you can do with it that are clever that other people have done, and we've sort of touched on a little bit. Kieran used it there as a little bit of an IDP chooser, SAML IDP chooser, and he also used it to show you protecting a classic website and APIs. You can also do some other stuff like hosting a static website on that, and we'll touch on that in some other sessions later in the series. But if you've got security questions or security problems, check out that API gateway. It does some interesting things you may not realize right away. And someone just asked a question, can you use a free tier? Yes, you can use a free tier account without using a credit card to explore the WAF services, the API gateway, all the services we've covered in here.
Awesome. Thank you so much, Kiran and Amit, for a great session, and really appreciate your time, Chris, for being here and answering the questions in the Q&A panel. Our next session on Monday, November 18th is titled Protect Your Tenancy from Ransomware-Style Data Integrity Threats. So in this webinar, you'll learn about the cyber resilience architecture and customer drivers. We'll outline the current threat landscape specific to ransomware-style threats. You'll learn about the industry trends and how to protect your OCI tenancy from ransomware-style data integrity threats again. So this will be the last security session this year, but we'll be back next year, same day, same time, with more sessions on Oracle Cloud Security. And as usual, you can register for any of our upcoming sessions from the Day One and Beyond Security series page or any other series that are available over there. You will also find the recordings of all our previous sessions on that page. So with that, thank you again, Chris, Amit, and Kiran. And thank you, everyone, for joining us. It was a great session. See you all next time. Have a great day, everyone.
Thank you.